This continues our lectures on section 3.1. We're going to do another example of a linear equation and graphing that linear equation into variables. So the first thing that we're going to do is we're going to find 3 points on this line. You might want to turn this video off and try it on your own and then come back and see how you do. So I'm just going to proceed from here. So I'm going to take the equation y equals 5/2, and I'm going to plug in our for our y-intercept. X equals 0 will give us our y-intercept, and of course that's going to give me the point -1. And so we're going to see that when we plug in x equals 0, our y-intercept is going to be a -1. Now we're going to go down to the next one. Now when you're dealing with fractions, what you want to do is you want to take a look at the denominator of your slope. Remember, that's the number that's multiplied by your x variable. And whatever that number is, in order to avoid fractions, you can use multiples of that number. So this is 2. So any even number I use, I'm going to end up with something that's not a fraction. So we're going to go ahead and we're going to use a positive 2. So I'm going to let x equal 2, and then I'm going to simplify. So the 2's are going to cancel here, and 5 times 1 is 5, and then -1, that gives me a +4, and now I have my second ordered pair. So when x is equal to +2, then my y is equal to +4. Now the next one I'm going to do a -2. And so now I have 5/2 times a -2. And I'm going to do my canceling here and here. That's going to give me a -1. And then -1 here. So 5 times a -1, which is a -5, minus 1 more, which 5 plus 1 is 6. And they're negatives, so there's a -6. And so that gives me my third ordered pair of x equals a -2 and y equals a -6. Now, of course, the next thing that we're going to do is we're going to go plot those ordered pairs. So my y-intercept first, x equals 0, y equals -1, and we want to put the ordered pair there as we graph that point, plot that point. And then our next ordered pair, x equals 2, y equals +4. Let's see, 1, 2, 3, and 4. And that gives us an x is equal to 2, and y is equal to a +4. And then last, we have x is equal to a -2, and y equals 1, 2, 3, 4, 5, and 6. And as in the last few examples, I don't have a straight line in this application, unfortunately, so I'm going to have to wing it. You should be doing this with a perfect piece of graph paper and a perfect straight edge, but I'll draw my straight line through these as close as I possibly can, and making sure, of course, that there are arrows on the end of this thing. I'm just kind of screwed up there. And then I label it with its name, its equation, which is y is equal to 5/2 x minus 1. And there we go. Now we have the plot of that line. So we have a t-table, which shows us a partial solution set. We have the equation, which shows us all solutions. We've plotted the 3 points on here to make our linear model, to make the straight line, which also shows all solutions. And then we could also read this in words, and this says that we're going to take our independent value, or we're going to take 5/2 of that, or we're going to multiply it by 2.5, and then we'll subtract 1 from that. So it's 1 less than 2.5 times the independent, which will give us our dependent each time. And that'll wrap up this linear model. Our next example, we're going to just take an example from the book.